So I gotta admit, I'm a little bit frustrated about this one because I fumbled the ball at the 90-yard line or maybe even the 95-yard line. But let's go ahead and look at the problem. I'm gonna break it down into 3 parts for you. So this is problem number 3 from assignment 5.1 on AP Classroom. The situation is we have 2 objects, both of them have separate angular velocities to begin, and then both of them encounter a alpha value, a negative angular acceleration, where one has an angular acceleration of alpha naught and the other has an angular acceleration of 2 alpha naught. Now we should note that these values of alpha are going to be negative values, and the reason we know that this is the case is because we're starting with an object that has a positive angular velocity, and then this object is going to 0 angular velocity. And we are told that each object goes to 0 angular velocity in the same distance, with that distance being defined as delta theta naught. So this is the information that we're given. One other piece of information that we can infer is that because the objects come to rest in this distance, that their final angular velocity is going to be 0. So what we're looking at is object 1, object 2, object 1, object 2, object 1 and 2 both have the same angular displacement by the end, so in radians. So to simplify, what I'm going to do is say that my angular displacement is 1 radian for each object. And I'm going to say that my angular acceleration is -1 for the first object, and then subsequently -2 for the second object. These values here are what our answers are going to be in terms of, so they're going to remain as they're enumerated. The equation that we're going to use based off the information that we're given is going to be this equation. This is final angular velocity squared equals initial angular velocity squared plus 2 alpha times change in angular position. And it's enumerated in the equation as theta final minus theta initial, but I'm going to just simplify it to this here. So we're going to use this equation for both objects. So I'll put object 1 here, and I'll put object 2 right here. So basically our final velocity is 0. Our initial velocity for object 1 is omega sub 1, we need to square it, plus 2 times alpha, which is -1, and then times this displacement of 1. So I pulled these values from right over here. My second object is 0 equals omega sub 2 squared plus 2, part of the equation, times -2 times 1 for our angular displacement. And so here's our 2 equations, and we're going to figure out numerically in terms of these made up values what each of these are equal to. So we simplify this to -2, so omega sub 1 squared equals -2, omega sub 1 squared minus 2 equals 0, and therefore omega sub 1 squared equals +2, and then omega sub 1 equals the square root of 2. This is familiar with what we ended up with in class. Likewise, if I go ahead and simplify this, we see that omega sub 2 squared equals 4, and therefore omega sub 2 equals 4. So basically, in terms of these made up numbers that I have found, we see that the angular velocity, the starting angular velocity of the first object was equal to the square root of 2 radians per second. And the starting velocity of the second object was at 4 radians per second. Or sorry, 2 radians per second, because the square root of 4 is 2. Now, this is where we got stuck, because we know that our answer is omega sub 2 equals omega sub 1 times the square root of 2. Now, how do we get this? How do we get from here to here? Well, here's the deal. If omega sub 1 is equal to the square root of 2, then how do we make omega sub 1 equal to 2? So that's our premise here. Omega sub 2 equals 2. What can we do to omega sub 1? What can we multiply by omega sub 1 to make it equal to 2? Well, to make the square root of 2 equal to 2, we need to multiply that by the square root of 2. So if we're going to do that to one side, we must do it to both. So basically, the square root of 2 is equal to 2, we multiply it by 2. And so omega sub 1 times the square root of 2 is equal to omega sub 2. And that's how we get our answer right here. Omega sub 2 is 2, and therefore, omega sub 1 multiplied by the square root of 2 is also equal to 2. So omega sub 2 is equal to omega sub 1 when it is multiplied by the square root of 2. And that, sorry about that, and that is how we derive the answer to this question based on this information. Now, what you'll find is because there is a proportional relationship between all these values, that you can put whatever numbers you want in for alpha and in for theta, and you're going to find that in every single scenario, the relationship is omega sub 1 times the square root of 2 equals omega sub 2. And I think Dell did a pretty good job of exemplifying that in class. There's more than one way to skin the cat. AP Classroom has a pretty good explanation as to why this is true, just in terms of variables. I myself prefer to make up values, simplistic values, as you see here, and utilize those values in order to determine a proportional relationship. And so that's how this proportional relationship was determined. Omega sub 1 equals square root of 2, omega sub 2 equals 2. The square root of 2 when multiplied by the square root of 2 is equal to 2. And since omega sub 1 is equal to the square root of 2, we must multiply it by the square root of 2 to get a value that is equivalent to omega sub 2. That's how you do the answer, and you can see now why I claim that I fumbled the ball at the 95-yard line. We made it to this point here, but didn't get a good explanation as to why omega sub 2 equals omega sub 1 times root 2. And that's because we need to multiply root 2 by root 2 to get 2. And that is the answer.